This is a recreation of the PopCan lab and is designed for those students who missed class earlier this week and could not complete the lab in class. Students who were in class to do the lab can also view this to get further observations. The situation is this. A pop can is filled with 70 milliliters of water, heated to a boil, then cooled in an ice bath. So here's our question. How do changes in temperature affect the reaction of the pop can? How do the changes in temperature affect the reaction of the pop can? You can write a hypothesis now. I'll go over the materials. Obviously, we're using the Bunsen burner as our heat source. That's connected to the gas hose, which is connected to the gas valve. We have the tripod. On top of the tripod is the wire gauze. On top of the wire gauze is a pop can that has been filled with 70 milliliters of water. Okay, what else do we need? Well, we're going to need beaker tongs. The graduated cylinder is out because I used it earlier to measure out 70 milliliters of water, and I poured that into the pop can. Some students took temperatures of the water in the ice bath during class or in class. This tub is where we will have our ice bath. It's filled with about 4 quarts of water, and I'm going to put some ice in that in just a minute. Actually, I'll put the ice in right now. Okay, so our water has been heating for maybe about 3 minutes now, and I'll go over some of the observations. Well, first of all, this is a 12-ounce can, and it's aluminum, so not very thick. Aluminum cans tend to be pretty flimsy. As the water was heating, a little bit of water vapor and steam started to pour out of the can. I think the water is actually starting to boil now, so I can hear it boiling, and I see from where I sit quite a bit of steam pouring out of the top of the can. You may not be able to see the steam on the screen, but I can see it from here. At the beginning, when I first started, there were a few water droplets on the outside of the can. Those water droplets evaporated very quickly. I'm going to turn this up just a little bit. So it's been almost about 5 minutes now, and again, more steam is still pouring out. I'm pretty confident the water's boiling right now. So maybe in another few seconds, I'm going to go ahead and get our ice bath put in position, and we'll cool the can and see what happens. What you should be thinking of right now also is what's happening to the molecules inside of the can. Remember, when I first started, there was about 70 milliliters of water in the can, and of course, the rest of the can was filled with air. So think about what happened to those molecules of water and air as the can was heated, and now it's boiling. Think about what the conditions might be like inside of that can. as well. What happened to the air? What is the can filled with right now? What is the pressure like between the inside and outside of the can? All those are good things to be thinking about right now. Okay, I think we're about ready. So I'm going to put the ice bath into place. Set it right here so you can see it. There. I'm going to get beaker tongues because we're going to use those. Many students recorded the ice bath at the surface to be somewhere around 45 degrees, maybe 45 degrees Fahrenheit. I won't take the temperature now, but many students reported around that temperature, 45 to 48 degrees Fahrenheit. Okay, so what I'm going to do is actually remove the can from the tripod, and I'm going to invert it into the ice bath. In other words, I'm going to take the can off of the tripod and put it into the ice bath in such a way that the opening hits the water first. The opening must go into the water first. If any other part of the can hits the water, what we want to happen will not happen. Okay, so we'll try it now. We'll see if I get this right. All right. On three. 1, 2, 3. Whoa, that was a good one. Okay, notice the shape of our can at this point. Wow, where did all that water come from? That was much more water than what we started with. Now I did actually drop the can. I didn't intend to drop it, but I dropped it into the water. But many students held on to their can and they lifted it straight out of the water and noticed that same thing, that a lot more water came out of the can than what was originally put into it. So why is that? Why did the can do this? Can you use what you've learned about the kinetic theory to this point to explain why the can behaved in this manner? Okay? Completely different from before. All right? The focus for this lab is on the conclusion and everyday life applications. So your final copy or final version of the lab that you turn in, of course, should have the conclusion and everyday life applications section typed.